is designed to help find the slope of a specific point in a function. Now, if you've heard of the difference quotient, as defined by mathwords.com, the difference quotient is defined as a formula that computes the slope of a secant line through 2 points on a graph. So, all the derivative is a simpler way to finding the slope of the tangent line at a certain point in the function.
F prime, also known as the velocity of a function, can be used to determine whether a function is increasing or decreasing on a given interval.
So, say you have the function f of x equals x squared plus 3x plus 1, and you want to find the slope of the point when x equals 3. The rule that you would want to use is f prime of x equals ax to the a minus 1. So that makes your derivative 2x plus 3. So to find the derivative of when x equals 3, you simply plug 3 back into the equation f prime. And so you figure out that f prime of 3 is 9. Now to find whether the function is increasing or decreasing on a certain interval, you use the critical points. Now to find those critical points, you set the derivative being f prime equal to 0. So once you solve the equation for what x equals, you'll find that it will equal negative 3 over 2. And that is your critical point.
Also use derivatives to figure out whether a function is increasing or decreasing. To do this, plug values greater than and less than the critical point into the derivative function. Y values that are positive mean that the original function is increasing, while y values that are negative mean the original function is decreasing. And if you were to actually graph the original function, you would see that you get a parabola.
With any function, there are several given derivatives. For example, sine x becomes cosine x. Cosine x becomes negative sine x. Tangent x becomes secant squared x. However, the function e to the x remains e to the x. Then, e to the f of x becomes f prime x times e to the f of x. And finally, ln of the absolute value of x, or just ln of x, becomes 1 over x. Now, let's try another example. Take the function 3x squared times ln of the absolute value of x all over 2x. So, to begin, you know that the x squared in the numerator and the 2x on the denominator cancel out, so that you are able to factor 3 over 2 out of the equation. Next, you're left with the function x times ln of the absolute value of x. So you're using the product rule to find the derivative of said equation. So, for your new function, you're left with x times 1 over x plus 1 times ln of the absolute value of x, thus making your final equation 3 over 2 times 1 plus ln of the absolute value of x. Now there is also the function f double prime. This is most commonly referred to as the second derivative, or it could be referred to as the acceleration of the original function. And f double prime is found by just taking the derivative of the first derivative, which is f prime.
Now, let's try another more difficult example. Now, let's look at an example of a double derivative. If you take the equation f of x equals x cubed minus 6x squared plus 9x plus 30, the first derivative would be 3x squared minus 12x plus 9. The double derivative would then be